Good morning. In our previous session, we have discussed about batteries, primary, secondary, and reserve batteries. What is a battery? Battery, when two or more galvanic cells are coupled with either in series or in parallel, it forms a battery, isn't it? So we have primary battery, secondary, and reserve batteries. Use and throw batteries are primary batteries. Secondary batteries are the batteries which can be used again and again. In secondary batteries, we have n number of examples: nickel metal hydride battery, nickel cadmium battery, lead acid batteries, lithium ion batteries. So today here we are going to discuss construction and working of one of the secondary batteries. The secondary batteries are rechargeable batteries. So nickel metal hydride battery. In nickel metal hydride battery, we have anode, cathode and electrolyte separator. So the anodic active species in nickel metal hydride battery is metal hydride. Cathodic active species is nickel oxyhydroxide. Electrolyte is potassium hydroxide. As it's an alkaline battery, you can use even in sodium hydroxide also. And anode and cathode electrolyte is separated by a polypropylene. So the metal hydride, which is the anodic active species, it might be any metal hydride. It might be vanadium, zirconium, titanium, etc. So any of this. Here the electrodes are, let us start with the construction of the nickel metal hydride battery. The electrodes are made up of porous nickel foil or grids. Both anode and cathode are made up of nickel foils or grids on which active species are coated. So anode or cathode both are made up of nickel foils or grids on which the active species. So at anode, the active species of anode is metal hydride. It will be coated, and it is a metal is cathode. The cathodic active species is nickel oxyhydroxide. It will be coated. So the anodic active species, any of the metal hydride, maybe vanadium, zirconium, titanium, chromium, so that will act as anodic active species. The electrodes are separated by a synthetic material such as polypropylene, which acts as an insulator between two electrodes and as an absorbing medium of electrolyte. The electrolyte used, as discussed earlier, is potassium hydroxide. So all these will be components will be enclosed in a steel container, and the battery looks like this. So now let us see what are the reactions which occur in anode and cathode. So at anode, so the metal hydride in presence of potassium hydroxide or in alkaline media undergoes oxidation. So metal, so here we have taken MH. So M is metal, H is hydride, right? So it can be any metal. It can be chromium, vanadium, zirconium, titanium, anything. So any metal hydride in presence of alkaline medium undergoes oxidation to give metal, water and an electron. So depending upon the oxidation state, okay, so it gives electron or electrons. So at cathode, what is the active species of the cathode? The active species of cathode is nickel oxyhydroxide. This nickel oxyhydroxide in presence of water accepts electron and gets reduced to nickel hydroxide. So the overall reaction is, so we have OH minus, right? So this OH minus will get cancelled. So we get nickel metal hydride plus nickel oxyhydroxide gives nickel hydroxide and metal. So this is the overall reaction. So this is during discharge. Okay. So during recharge, it will be the other way around. So these reactions are reversible reactions. All these forward reactions, whatever we are saying, it is during discharge. So during recharge, so all these reactions will be reversed. So all reactions are reversible. So let us see what are the advantages of this nickel metal hydride battery. The capacity of nickel metal hydride battery is high. So it is having long shelf life. What is shelf life? So I am taking a battery. So this is a battery. So as discussed, when I manufactured it, so the output of this was found to be 5.1 volts. Right. So after 2 years, I'm not going to use it for 2 years. So after 2 years, one day, if I'm going to open this battery and use it, if I find to be having 5.1 volts only, then the shelf life is 5.1. Okay, so again, if I'm same another battery, I'm going to take it, and if not using for 10 years, okay, and after 10 years, the next day, immediate next day, if I'm checking it, if the battery is showing the same output on same day when it was manufactured, then it is shelf life is 10 years. If it is lesser than that, then it will be keep on increasing. So the shelf life is, so without discharging the battery, how many day time, how much of time the battery can be stored without self discharge is called as shelf life. So nickel metal hydride battery has long shelf life. So it is very simple to store, and since it can be obtained in different, I mean, smaller form, bigger form, it is easy to transport too. It is environmental friendly. Why it is environmental friendly is the reactions which occur inside the nickel metal hydride battery are non-toxic. The products are non-toxic. Since the products are non-toxic, it is environmental friendly. For example, if you consider lead acid battery, it's a secondary battery, so the products are highly toxic. Maybe because it forms lead sulfate, right? And we are using acid there, sulfuric acid, and the product formed is lead oxide and lead sulfate. So since it is formed by lead, what will happen? The products are highly toxic. Okay, so these are the advantages of nickel metal hydride batteries. So let us see what are the limitations of this nickel metal hydride battery. So this disadvantage or limitations so called, so it is limited to service life, it's having limited service life, so limited discharge current, high self discharge, and high maintenance. So the maintenance cost of these nickel metal hydride batteries are high. So these are some of the disadvantages of nickel metal hydride battery. So let us see the applications or uses of the nickel metal hydride batteries. These are used in cellular phones, used in power tools, portable electrical vehicles or e-vehicles. It might be e-bike, e-vehicles, right? So you have car, electric, which is run by electric current. So it is used in all portable electric vehicles, power tools. For example, you have a drilling machine, right? So drilling machine also needs a power. So now we have a drilling machine with battery. So even there it can be used. Cellular phones, not our this normal mobile phones. So cellular phones, it is used. It is used in laptops. It is used even in spacecrafts. So these are the applications of nickel metal hydride battery. So later, after the R&D is done, so later this slowly the nickel metal hydride battery was replaced by nickel cadmium battery, and later we are going to use only lithium ion battery. So in almost all electrical vehicles, in our cell phones, in laptops, what are we going to, instead of using this nickel cadmium or nickel metal hydride battery, it is replaced by lithium batteries. So this is regarding the nickel metal hydride batteries. So in our next discussion, we are going to discuss about lithium batteries or lithium ion batteries. So these lithium ion batteries are commonly used batteries, so all of you are familiar with. We're going to discuss in the next session about lithium ion batteries. Thank you.